minus 5 which is equals to minus 4, and here Z2 that is minus 2 minus 4 which is equals to minus 6. So the direction ratio for PQ it is equals to 3 comma minus 4 comma minus 6. The direction ratio for the two given points. Hi guys, this is the first part of the topic three-dimensional geometry. In this video, I'm going to explain you how will you find the direction ratio for the given 2 points. Now as you can see on your blackboard, there are 2 points P and Q having the coordinates 1, 5 and 4 for the P and the coordinates 4, 1 and minus 2 for the point Q. And we have to find the direction ratio of the point of PQ. Now the formula for finding the direction ratio is very simple. X2 minus x1, y2 minus y1 and z2 minus z1. Okay. So this is x, this is y, this is z. So this is x1, y1, z1. This is x2, y2, z2. So x2 minus x1. So this is x2, that is 4 minus 1, which is equals to 3. Then 1 minus 5, which is equals to minus 4. And here z2, that is minus 2 minus 4, which is equals to minus 6. So the direction ratio for PQ, it is equals to 3 comma minus 4 comma minus 6. So in this way we can easily find out the direction ratio for the two given points. To the second topic, how will you find the direction cosines? Now what are the direction cosines? If the vector makes any angle, let it be alpha, beta and gamma, with the axis of x-axis, y-axis and z-axis, then the cos alpha, cos beta and cos gamma are called the direction cosines. And direction cosines are also denoted by the L, M and N. Now this is the theoretical concept. Now if applying on these types of question, how will you find the direction cosine? For example, the question given to us is that if a line has direction ratio 2, minus 1, minus 2, and we have to find the direction cosines. So now here these are the direction ratios. So direction ratios, it is given 2, minus 1, minus 2. We can denote it by A, this is B and this is C. Now the formula for the direction cosines, I have told you cos alpha, it is generally denoted by L, and which is equal to A upon under root A square plus B square plus C square. Similarly, cos gamma, cos beta, which is M, and cos gamma, which is equals to N. Okay, firstly I am going to solve this, then for cos beta, then for cos gamma. Now the value of A is 2 and it is under root 2 square plus minus 1 square plus minus 2 square. Okay, now it becomes 2 under root 4 plus 1 plus 4. That means 2 over under root 9, and we ultimately got 2 by 3. Similarly, when we have to solve for the cos beta, then what we have, cos beta, which is M. Now first one, cos alpha, that is L, we get 2 by 3. Okay, now here we just simply add B for cos beta, and here we put the ratios are given, you can easily find out the direction cosine. The main formula is that is a over under root a square plus b square plus c square. I think concept is clear to you now. Now, the next type of questions regarding direction ratios. Now, if the equation of line is given in this format and it is said to you, then find the direction ratios and direction cosine for this equation of line. Okay. Now, firstly, understand how will you write. Firstly, I am going to tell you how to write the direction ratio. Then I will tell you how to find the direction cosine. Okay. Now, generally, the equation of the line is x minus x1 over a, y minus y1 over b, and z minus z1 over c. Okay. Now, comparing these two equations, we can observe here we have minus x. So, just make these equations in the correct format. So, from here we get x minus 3 over minus 1 is equals to y plus 2 over minus 2 is equal to z minus 5 over 4. Okay. Convert. Now these a, b and c. This is our direction ratio. What is this? This is the direction ratio. So it's very easy. Direction ratio for this line is what? Direction ratio is minus 1, minus 2 and clear. Now I'm coming to the topic. How will you find the direction cosine? Direction cosine. Okay. Now n is equal to a over under root a square b square plus c square. M is equals to b over under root a square plus b square plus c square. Now n is equal to c over under root a square plus b square plus c square. So substituting all the values, a is minus 1 over what? This is minus 1. Now minus 1 square plus minus 2 square plus 4 square. Okay. Similarly here we get minus 2 over under root, putting all the values similarly, minus 2 square plus 4 square. I think you can easily find out the answer now. Is obvious. The main confusion between direction cosine and direction ratios, I think it must be clear to you. Now when we solve, this is 1, this is 4, this is 16. So ultimately what we get, minus 1 over 1 plus 4 plus 16. Okay. That is under root 21. That is minus 1 over under root 21. This has become minus 2 over under root 21. And similarly 4 over under root 21. So these are the direction cosines. Okay. So when the equation of line is given in the Cartesian form, this is the equation of line in the Cartesian form. Okay. And this is the format for the equation of line in the Cartesian form, where a, b, c are the direction ratios and x1, y1, z1 are the points. Okay. I will explain these concepts in a little bit later. Now see the next question. If the equation of line is this, find the dr, that is direction ratio, and dc, direction cosine of the line parallel. अभी तक जो लाइन थी वो दे दिया, मैं उसी का डायरेक्शन रेशियो और डायरेक्शन कोसाइन निकालना होगा। अब ये जो लाइन की इक्वेशन दी हुई है, इस लाइन की इक्वेशन की जो पैरेलल लाइन जा रही है उसका डायरेक्शन रेशियो और डायरेक्शन कोसाइन निकालना है। तो सबसे पहले हमारा ये जो फॉर्मेट है इसको हम चेंज करेंगे। देखिए हो जाएगा x minus 5 by 2 and 4 by 2 is equals to y plus 4 by 3 which is equal to z minus 6 minus 6. That means we make x, y and z and simply we divide all these things to make it this way. Okay. Now here we get what? We get 2. Clear? 2, 3 and minus 6. Now it's very easy. Always remember direction ratios are same for the two lines which are parallel to each other. So the direction ratio for this line is 2, 3 and minus 6. Simple. Okay. So don't be confused if it is given that find the direction ratios and cosine for the line parallel to the given line. Now direction cosine, simply we again remind you formula a over under root a square plus b square plus c square. So what we have? 2 over, now when we solve it, 2 square, 3 square and minus 6 whole square. So what we get? 2 2s are 4, 3 3s are 9, 6 6 are 36. So we get under root 49 and we get 2 by 7 which is equal to L. Now m is equals to 3 by 7 and n is equals to minus 6 by 7. So these are the direction cosines and this is the direction ratio. If you are watching this video, here we learn how to convert any Cartesian equation into its vector form. There are two ways by which we can write any equation of line. First in the Cartesian way and second in the vector way. What is the Cartesian way? When we use the x, y and z in our equations, then it is Cartesian equation, and when we have I, z and k, then it is in the vector form. Now firstly I am going to explain you, if any Cartesian form of equation of line is given and we have to convert it into the vector form, how will we do that? Okay, so these are the points from where the line passes. Okay, so the points are x minus 5, that is 5, that is y plus 4, that is minus 4, and z minus 6, it is 6. How can we solve it? That is, we write x minus 5 is equal to 0, so x is equal to 5. Similarly, y plus 4 is equal to 0, so y is equal to minus 4. So in this way we get these. These are the points from where this line passes. Now the direction ratios. Direction ratios are given in the denominator. So we have 3, 7 and 2. Okay. Firstly, whenever there is a Cartesian form of line, find out the points and the direction ratio. Now I am going to write this equation of line into the vector form. Okay. For writing the vector form, you just remember formula a plus b lambda. Okay. From at the point A, we write the points, and for the B, we write the direction ratios. Okay. So from here, from at the point A, we have 5 minus 4 and 6. So we write it is in the way 5i minus 4j plus 6k. Okay. Put it in the bracket plus lambda, a constant, and 3i, for the x-axis we use I, 7j and 2k. I think it's very simple now to you. How will you convert the Cartesian, the line written in the Cartesian equation into the vector form? The equation of the line is a plus lambda b. Okay. Now we convert if the equation of line given in the vector form to our Cartesian form. Okay. So as we know, In the vector form, the equation of the line has the format r is equal to a plus lambda b, where a is the points and b is the direction ratios. Clear? So, comparing with these, we know in the Cartesian form we have the standard form of equation x minus x1 over a, y minus y1 over b, and z minus z1 over c. Now we firstly find x1, y1 and z1 for this line. First question I am going to take. So these are the points. So from here, x1, if we compare, r is equal to 2i plus j minus k plus mu 2i plus j plus 2. Now listen one thing clearly. These are the points. These are the points. And these are the direction ratio. Direction ratio. Must remember. Okay. So from here, this is x1. This is j. That is coefficient is 1. And z1 is minus 1. So from here, we have x1 is equal to 2. Y1 is equals to plus 1. And z1 is equal to, that is minus 1. Okay. Now from here, direction ratios, a is equals to 2, b is equals to 1 and c is equals to 2. Now substituting all the values in the standard form of equation, we get equation of line x minus x1, that is 2 over a, that is 2, which is equals to y minus 1 over 1, and it is equals to z, which is minus 1, so it becomes plus 1 over 2. Okay, so in this way you can very easily convert any vector equation into the Cartesian equation. Okay, now I am going to again solve one more question regarding these concepts. Okay, now the next question which is given, it is little bit complex. We have r is equal to 1 plus 2 lambda I plus 1 minus lambda c plus lambda. We just elaborate it and we get 1 into I, that is I, plus 2 lambda I plus j minus j lambda, then lambda. Okay, take all the values on one side, I plus j, and there is no k, so okay, then plus 2 lambda I minus j lambda plus lambda. Okay, so I think you can now easily got the point which I want to clarify with you. We get 2i minus j plus k. Okay, so this is the what? Direction ratio, and this is the points. So x1 is what? 1, y1 is what? 1, and z1 is 0. Okay, from here a is equals to 2, b is equals to minus 1, and c is equals to plus 1. Substituted in the standard form of the equation, we get what? What is the equation of the line in the Cartesian form? I told you earlier, x minus x1 over b is equal to y minus y1 over b is equal to z minus z1 over c. So substituting all the values, we get x minus x1, that is 1, over a, that is 2, which is equal to y minus y1, that is 1, over b, that is minus 1, and z minus 0, because y1 is 0 and c is 1. So this is the required equation of the line. So in this way you can easily convert any Cartesian form of equation to vector form, any vector form of equation to Cartesian form. This is the first part of the topic 3 dimension. अगर आप ये वीडियो देख रहे हैं तो ये वीडियो कोऑर्डिनेट ज्योमेट्री का क्लास 12th में 3D ज्योमेट्री जो है 3 डायमेंशनल ज्योमेट्री उसका मैं थर्ड पार्ट ये आपके सामने बना रही हूँ। इसमें मैं शॉर्टेस्ट डिस्टेंस बताऊँगी दो लाइनों के बीच का। तो आपको पहले इधर फॉर्मूला दिख रहा होगा, इतना बड़ा फॉर्मूला है x2 माइनस x1, y2 माइनस y1, z2 माइनस z1, फिर a1 b1 c1, a2 b2 c2, फिर नीचे अंडर रूट में इतना लिखा हुआ है। ये फॉर्मूला अभी जैसे से मैं क्वेश्चन करूँगी तो आपको बहुत आसानी से याद हो जाएगा। अब मैं आपको ये बताने जा रही हूँ। अगर आपको इसके पहले के 2 वीडियोज़ और देखने हैं तो आप लिंक से पहुँच सकते हैं जो मैंने नीचे दिया हुआ है वीडियो के साथ अटैच करके। तो चलिए अब क्वेश्चन सॉल्व करते हैं। आपके पास ये दो लाइन x माइनस 1 1, y माइनस 2 माइनस 1, z माइनस 1 1 और दूसरा इक्वेशन ऑफ लाइन ये। यहाँ पर आपको हम बता दें ये और ये x1 और ये x2 है। तो आप पहले सारा एनालाइज करें। x1 की वैल्यू ये x माइनस 1 है तो ये 1, y1 की वैल्यू 2, z1 की वैल्यू 1, यहाँ पर ये 2 है तो x2 की वैल्यू 2, ये प्लस 1 है, y2 की वैल्यू माइनस 1, ये z2 हो गया तो z2 की वैल्यू माइनस 1। इसी तरह ये a1, ये b1, ये c1, a1 1, b1 माइनस 1, c1 1, a2 2, b2 1, c2 आपका 2। देखिए समझ लीजिए, जैसे एक इक्वेशन ऑफ लाइन दिया तो ये आपका x1 y1 z2, ये नीचे वाले आपके a b c, एक हमने लिया तो a1 b1 c1 a2 b2 c2। इस तरह से आप पहले इसको एनालाइज कर लीजिए क्या वैल्यूज है, इसके बाद हम इसको फॉर्मूले में रखेंगे। तो आपकी पहली लाइन में क्या है कि x2 माइनस x1, y2 माइनस y1, यानी ये जो ऊपर की वैल्यूज हैं आपको इनको माइनस करना है। ठीक है, तो यहाँ पर देखिए x2 माइनस x1 यानी 2 माइनस 1, यानी शॉर्टेस्ट डिस्टेंस में आपने क्या रखा 2 माइनस 1, फिर आपका क्या है y2 माइनस y1, ये देखिए माइनस 1 फिर माइनस 2, माइनस 1 माइनस 2, फिर आपका थर्ड नंबर पे क्या है z2 माइनस z1 यानी माइनस 1 माइनस 1। ठीक, उसके बाद आप यहाँ रखिए a1 b1 c1 a2 b2 c2, आगे रखते जाइए 1 माइनस 1 1 2 1 और 2। अब आपका नीचे इतना बड़ा फॉर्मूला लिखा हुआ, अगर आप इसमें कंफ्यूज हो रहे हैं तो मैं आपको इसकी ट्रिक बताती हूँ। जिस तरीके से हम लोग डिटरमिनेंट सॉल्व करते हैं तो आप ये देखिए ये 3 रोज कॉलम का 3 बाई 3 का डिटरमिनेंट है 1 2 3 1 2 3। अगर आप इस कॉलम के लिए लेके चलेंगे तो आपको ये दोनों को मल्टीप्लाई करना है, आपको ये डिब्बा मल्टीप्लाई करना है माइनस 1 1 1 2, तो आप इसको मल्टीप्लाई करोगे तो माइनस 2 और फिर माइनस लगा के माइनस 1, आपका ये आ गया माइनस 2 और माइनस 1, फिर प्लस हो गया। इस सेकेंड वाला है तो हमने सेकेंड छुपा दिया। अब हम इसको और इसको मल्टीप्लाई करेंगे 2 इंटू 1 और माइनस 2 इंटू 1, इसको डायरेक्ट 2 लिख देंगे, दैट इज 2 माइनस 2 2 और माइनस 2। नाउ थर्ड वन आपने इसको ड्रॉप किया तो आपका ये जो सेकेंड टर्म होता है ये माइनस करके लिखा है, तो आप यहाँ पे क्या लगा लीजिए माइनस 2, यहाँ पे अब ये थर्ड वाला है तो 1 1 जा 1 और ये प्लस 2 बच। ठीक है, ये बात आपको अच्छी तरह से समझ में आ गई। तो यहाँ पर प्लस ही रहेगा 2 1 जा 2 और ये माइनस 2। क्लियर, मतलब आपको ये समझना है कि जैसे आपने ये बना लिया तो आप ये जो नीचे वाला डिटरमिनेंट है इसी को आप सॉल्व करके यहाँ लिखिए। जैसे फर्स्ट टर्म के लिए हम पहले ये बॉक्स लेते हैं ये वाला, सेकेंड टर्म के लिए इसको ड्रॉप करके ये और ये बॉक्स लेते हैं, थर्ड टर्म के लिए हम केवल इतना बॉक्स लेते हैं, ये हमने यहाँ पर लिख दिया। अब हम इसके बाद इसको फिर से आगे सॉल्व करेंगे। आप इसको सॉल्व करेंगे तो आपका देखिए क्या मैं ऐसे लिख रही हूँ 2 में से बन गया 1, ये आपका माइनस 3, ये आपका माइनस 2, यहाँ आपका 1 माइनस 1 एंड 1 इंटू 1 एंड 2, नीचे आपका क्या आएगा, आप इसको सॉल्व करिए, ये हो गया x2 minus x1, y2 minus y1, z2 minus z2। फिर आप नीचे की जो डायरेक्शन रेशियोज है उनको लिखेंगे a1 b1 c1 a2 b2 c2। और ये वाली जो इतनी लंबी लाइन अगर आपको याद ना हो तो आप यहीं से याद कर लीजिए कि आपने फर्स्ट वाला जब दिया तो आपने केवल ये बॉक्स दिया b1 c2 माइनस b2 c1 और फिर होल स्क्वायर लगाया। सेकेंड में आपने क्या किया, ये लाइन ड्रॉप करी, आपका क्या हो गया a1 c2 माइनस a2 c1, ठीक है, होल स्क्वायर। फिर आपने जो थर्ड बॉक्स लिखना है वो आपने ये लाइन ड्रॉप की a1 b2 माइनस a2 होल स्क्वायर। दिक्कत क्या है कि फॉर्मूला याद हो जाए तो हमारा कोई भी क्वेश्चन आसानी से हो जाएगा। आप प्रैक्टिस कीजिए, आपको आ जाएगा। उसके बाद हम आपको बताने जा रहे हैं अगर इक्वेशंस वेक्टर फॉर्म में दी हुई हो तो उनके बीच में शॉर्टेस्ट डिस्टेंस कैसे निकालते हैं। Now students, as I told you earlier, I am going to find out the distance between two equations of line if they are given in the vector form. So this is the vector form of equation. That is, it is given into form of I plus j etc. That is, it is given in the form of r is equal to a plus lambda b. Okay, this portion is termed as a part and this with the lambda coefficient, this is the b part of the vector equation of the line. Now our formula is b1 cross product b2 dot product a2 minus a1 over mod of b1 cross b2. That means we have to find b1 cross b2 ultimately in our first step. Okay, before doing that I will just recognize all the parts of our two lines. Let considering this is a1 which is equal to I plus j. Okay, this is a2 which is equal to 2I plus j minus k. Similarly, b1 is 2I minus j plus k and b2 is 3I minus 5j plus 2k. Now, using these statistics, we find the distance between the two lines given in the form of vector. We have to find firstly b1 cross b2. Okay, so b1 cross b2. For this, we write here I, j and k. Now b1 is that one, that is we just write 2, it is minus j, that is minus 1 and plus 1. Now for b2 we have 3, minus 5 and 2. Okay, now we solve this, we have I minus 2 plus 5, put over minus j again. Okay, note it down, then 2 2s are 4 minus 3, then plus k, we have 2 5s are 10 plus 3. Okay, now after that we get 3I here minus j, then minus 7k. So this is the value of b1 cross b2 which we are going to put over here. Now we also have to find mod of b1 cross b2. That means we have to find the magnitude of this portion. So mod of b1 cross b2, it is equal to under root of 3 square magnitudes of ijk plus minus 1 whole square plus minus 7 whole square. Okay, we have to find the square of the magnitude of ijk. Plus 1 plus 49. That we have under root 59. Okay. Now we substitute both the values b1 cross b2 and mod of this in our equation. We just write over here b1 cross b2, it is equal to 3I minus j minus 7k and mod of b1 cross b2 we got under root 59. Okay, now I'm just going down. Now substitute the values which we have evaluated here in the formula. Before doing that, we also have to find a2 minus a1. We have to find a2 minus a1. Now the value of a2 is what? 2I plus j minus k and a1 is I plus j. we have to subtract them, so change the sign over here. We get I, it is get cancelled, then plus, so we have I minus k over here. Okay, now substituting these values in our equation, what we get, distance between the two lines is equal to mod of v1 cross v2, that is 3I minus j minus 7k. Now dot product of I minus k over under root 59. Here we have to find the dot product. Okay, that means 3 into 1, that is what? 3. J is 0, that is 0, and k is minus 1 plus 7 over under root 59. So our answer is 10 over under root 59. So in this way, shortest distance between two lines can easily be calculated if we know the formulas for both of the methods, by the Cartesian method also, by the vector methods. If you like the videos and if you want to watch some more videos, you can go through the link which I have just shared in the contents or description box of the videos. Thank you. Okay, now we have to find the shortest distance between them. Formula is x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, upon under root b1, c2 minus b2, c1 whole square plus a2, c1 minus a1, c2 whole square plus a1, b2 minus a2, b1 whole square. This is the formula. Okay. Now we have to perform one by one. Standard equation of Cartesian equation is x minus x1 over a1, let it be a, y minus y1 over इसमें सबसे फर्स्ट टॉपिक मैं आपके साथ जो शेयर करने जा रही हूँ कि किसी प्लेन का ओरिजिन से डिस्टेंस निकालना है, यानी डिस्टेंस ऑफ अ प्लेन फ्रॉम ओरिजिन हम किस तरीके से निकालेंगे। हमें पता है कि ओरिजिन होता है पॉइंट 0, 0। तो मान लीजिए मेरी इक्वेशन ऑफ प्लेन दी हुई है 3x plus 4y plus 12z is equal to 5, and we have to find the distance of the plane from the origin. तो इसका फॉर्मूला होता है origin से निकालने के लिए, this is d, that is mod of d under root a square plus b square plus c square, all the coefficients x, y and z. So very simple. So what is the value of d over here? Mod of 5 under root 3 square plus 4 square plus 12 square. When we solve, we get 5 over 3 3s are 9, 4 4s are 16, then 144, and when we sum up, we get 5 over under root 169, which is equals to 5 over 13. So in this way, we can find the distance of a plane from the origin. अब इसी में next step we have to find a distance between the point in a space and the plane. For example, the equation of plane is given as 3x minus 4y plus 12z is equal to 3, and the point is 6, 5, minus 2, from where we have to find the distance. So for that, formula is ax1 by 1 CZ1 plus D, we have to take the absolute value over under root A square plus B square plus C square. Now this is the equation of the plane, where that means format is equation of the plane is AX plus BY plus CZ plus D is equal to 0, and the point is in the format x1, y1, z1. That means we put different points x1, y1, z1 in place of x, y and z. So according to this, we proceed in this way. We have the equation of the plane 3x minus 4y plus 12z is equal to 3. So equation of plane is reduced in this form: 3x minus 4y plus 12z minus 3 is equal to 0. Make the equation of plane in this form and then substitute the value of the points in place of x, y and z. So distance between plane and the point is mod of 3 into 6 minus 4 into 5 plus 12 into minus 2 and minus 3 under root coefficient of x, that is 3 square, coefficient of y minus 4 square, and coefficient of z, that is 12 square. So ultimately what we get: 18 minus 20 minus 24 minus 3 over 3 3s are 9, 16 and 140. Now when we solve, we have to add up all of them, that is 27, that is 47, 47 minus 18, 47 minus 18, 29, that is minus 29 over under root 169, that is 29 over 13. So this is the distance between plane and the point which is given. So this formula is used when you have to find the distance between the plane and the point. In the Cartesian form and in the vector form, when the 3 points are given to us. Now, firstly, what is the equation of plane in the Cartesian form? For example, 3 points which are given as x1, y1, z1, x2, y2, z2, and x3, y3 and z3. These 3 points are given to us and we have to find the equation of plane. The equation of plane is in this form: x minus x1, y minus y1, z minus z1, then x2 minus x1. Similarly, y2 minus y1, z2 minus z1, and x3 minus x1. Similarly, y3 minus y1 and z3 minus z1. This is the equation of the plane in the Cartesian form. When you derive the equation of plane in the Cartesian form, then you have to convert this equation in the vector form. I will tell you one by taking an example, and then I also convert this equation of Cartesian form then to vector form. Now for example, the 3 points which are given to us are, and we have to find the equation is, for example, we have 3 points, 3 comma minus 1 comma 2, and the next 3 points which are given to us 5, 2 and 4, and next 3 points they are minus 1 and 6, and we have to find the equation of the plane. Now this is x1, y1, z1, this is x2, y2, z2 and similarly. So in place of x1 what we write? 3. In place of y1 we write minus 1. Then in place of z1 we write 2. Okay. Now x2 minus x1, this is x2, that is 5 minus 3. 5 minus 3. Now here we get y2, that is 2 minus 1. Similarly, 4 minus 2. Now x3, what is the value of x3? The value of x3 is what? Minus 1. Minus 1 minus 3.